You're in the bath, phone held just above the waterline, scrolling through nothing in particular. Steam fogs the corner of the mirror. Your other hand is submerged, fingers loose, doing nothing at all, just resting under the surface while the water goes from hot to lukewarm and you lose track of time entirely. 15, 20 minutes pass without you noticing a single one of them. You lift that hand out to grab your towel and stop. Your fingertips look like they belong to someone 40 years older. Ridged, pale, pruned, like the years just skipped ahead while you weren't paying attention, and nobody warned you. That's not damage. That's not your skin failing, softening, or breaking down after too long in the water. That's your nervous system, on purpose, redesigning your hands in real time, sending a specific signal, executing a specific plan, and quietly undoing all of it the moment you dry off. This video is about why human skin wrinkles in water, specifically why it only happens on your fingers and toes, why it takes about 3 to 5 minutes to start, why it forms the exact pattern it forms, and why your body appears to have built this feature deliberately, rather than it simply being passive water damage. By the end of this, you'll understand why a wrinkle isn't a symptom of anything going wrong. It's a tool, one your body has been quietly building, testing, refining, and hiding in plain sight for your entire life, and you've never once been told it was there. For most of the 20th century, the explanation taught in biology classes was simple. Water passes into the outer layer of skin, the keratin swells, and the surface puckers upward. Passive, mechanical, basically a raisin with a heartbeat, and nobody questioned it much further than that. That explanation has a hole in it, and the hole has been sitting there since 1936. Physicians documenting patients with certain nerve injuries in the hand noticed something they couldn't explain using the swelling theory at all. Those patients stopped wrinkling in water entirely, even when the skin itself was completely undamaged and still fully capable of absorbing moisture like normal skin. If wrinkling were purely a matter of water swelling dead skin cells, a severed nerve pathway shouldn't change the outcome in the slightest. Skin doesn't need permission from the brain to absorb water, but apparently, it needs permission to wrinkle. That single clinical detail sat there for decades, cited occasionally in medical journals and mostly ignored by everyone else, for close to 80 years before anyone took it seriously enough to build an entire competing theory around it. In 2013, neuroscientist Mark Changizi and his colleagues proposed a reframing that turned the whole phenomenon upside down. Wrinkled fingers aren't swelling. They're tire treads. His team mapped the geometry of wrinkled fingertip skin under close analysis and found the pattern wasn't random, puckering at all. It consistently formed branching, tree-like channels, the same kind of drainage architecture you'd find carved into a river delta from above, or the tread grooves deliberately engineered into a car tire to channel water out from under the rubber. Structures built specifically to move water away from a contact surface, not structures that form from simply soaking it in and swelling passively. To actually test whether this improved grip in practice, a 2013 study out of Newcastle University had participants handle wet objects, marbles, mostly moved one at a time between containers, comparing performance with pruny, wrinkled fingers against smooth, unwrinkled ones. People with wrinkled fingertips transferred the wet marbles measurably faster with a consistent margin across trials. But when the exact same task was repeated using dry objects instead, the advantage disappeared completely. Dry-fingered and wrinkled-fingered participants performed identically either way, no difference at all. The wrinkles only helped in water. On dry ground, they did nothing whatsoever, which is exactly what you'd expect from a purpose-built drainage system switching on only when needed, and exactly what you would not expect from ordinary, undirected swelling. This is where that decades-old nerve observation comes back around and finally makes sense. Wrinkling is governed by the sympathetic nervous system, the same branch responsible for fight-or-flight responses, involuntary sweating, and pupil dilation under stress or fear. When nerve endings in your fingertips register sustained moisture over several minutes, blood vessels underneath the skin constrict on command from that system. That constriction physically pulls the skin down into its pleated, ridged pattern from underneath the surface. Rather than the surface itself changing shape on its own, it's an active, centrally controlled response, not passive absorption happening quietly at the surface layer, which explains why anesthetic nerve blocks to the hand, used routinely in certain surgical procedures, leave fingers completely smooth even after extended full submersion in water. No nerve signal reaches the vessels, no constriction happens, no wrinkle forms. The water is there doing exactly what water does. The instruction to respond to it simply isn't. Your fingertips are being told what to do, on a schedule your brain sets entirely without asking you first. The timing lines up with a why too specific to be accidental. Wrinkling reliably begins somewhere around the 3 to 5 minute mark of continuous submersion, which happens to be roughly the same window where wet hands genuinely start losing meaningful grip on smooth, dry handling surfaces. Not instantly, the way you'd expect if this were a simple water absorption reacting the moment skin touches liquid. Not after an hour, the way you'd expect if this were irrelevant background noise the body ignored. Right around when it would actually start to matter for handling something in a real situation. Researchers extending. Janjizi's original evolutionary framing have argued this precise timing points toward a specific ancestral use case. Wading through shallow streams, tide pools, or rain-slicked terrain to gather food, forage shellfish, or handle wet prey, where slippery footing and slippery hands together represented a direct, repeated, physical threat to survival. A 3 to 5 minute delay is short enough to switch on well before any serious foraging or wading in water gets underway, but long enough to avoid triggering unnecessarily over a brief rain shower or one accidental splash from washing your hands at a sink. That's not a malfunction curve, and it's not a coincidence either. That's a threshold, tuned with real precision by something that had a very specific, recurring problem to solve. Only fingers and toes do this, not forearms, not the palm in general, not the back of your hand, not your face or your neck, specifically the pads, the exact surfaces that make first direct contact with objects, ground, and terrain when you're actively using them. Every other water-exposed patch of skin on your body just swells, normally, briefly, and evenly, the way the old textbook explanation describes. No branching pattern forms. No drainage channel appears. No measurable grip advantage results, because there's nothing on those surfaces designed to produce one in the first place. Which effectively rules out the idea that this is some generic side effect of skin simply being skin, exposed to water for long enough. It's localized to a precise, narrow set of surfaces, activated on a precise delay measured in minutes, producing a precise, repeatable geometric pattern every time. 3 separate specifics stacking directly on top of each other in a way that pure, passive water absorption has no clear reason to produce on its own. Here's the wrinkle in the story, so to speak. Not every scientist agrees this is confirmed evolved function rather than a convenient, well-argued coincidence. A 2020 replication attempt tried to reproduce the original wet grip advantage under controlled conditions and found the effect was inconsistent. Present for some objects, essentially absent for others, and noticeably smaller across the board than the original Newcastle results had suggested. Some researchers now argue wrinkling could be a useful byproduct of nerve and blood vessel behavior that evolution never specifically selected for on its own, a bonus feature riding along on a system that was built to do something else entirely, not a blueprint drawn up specifically for improving grip underwater. Nobody disputes that the nervous system is deliberately, actively controlling this process on a fixed schedule. What's genuinely still unsettled in the research is whether controlled on purpose also means built for this exact purpose, or whether your body simply inherited a useful side effect somewhere along the way and kept it around because it never cost anything to keep, and occasionally helped. Even the tidiest story your body tells you, it turns out, has an asterisk hiding somewhere in the footnotes. You're still in that bath. Phone still in your dry hand, screen long since dimmed and forgotten. But your other hand, the wrinkled one, isn't damaged, isn't waterlogged, isn't aging in fast forward beneath the surface. It's your nervous system, mid-decision, quietly re-engineering your grip for a threat your body still half remembers, even in a room with no current. No slick rocks underfoot, no fish to catch, nothing at all left to forage. Some part of you is still preparing for a river that isn't there,